Hi, Honors Algebra 2. This is lesson 14. Today we're going to be talking about complex numbers. So there's a lot. I encourage you guys to pause this video as needed and restart whenever you have time to take some more notes and try some more examples. But first we're going to be talking about adding, subtracting complex numbers and what a complex number is, what an imaginary number is, and then we'll move on to multiplying and dividing, finding complex conjugates. So here we go. First of all, I comes from a guy named Euler, and he made up that the square root of -1 could represent I, so that we don't have to stop doing everything when we get a square root of a negative, which, as you guys know from doing some quadratic stuff, that can happen. So basically he said, well, let's just call I the square root of -1, and then let's see if we can just keep going in math. And it actually allowed for a lot of other advancements in engineering and electrical engineering. So we usually do some of that in class, and we'll probably do some of that when we see you guys second semester, but for time's sake, we've cut out the electrical piece of this lesson, and we're just focusing on what I is. Okay. So this is where I stands over here in this imaginary number field. It's part of the complex numbers, and we're going to be talking about complex numbers with imaginaries in here in just a second. So first of all, when we are simplifying, when you're just simplifying or evaluating something, we don't have to consider our plus or minus option. So remember that. And so we just want to know what is the square root of -1, and that is actually just I. I is the square root of -1. So just like when we simplify radicals before, you would say, well, this is really the square root of -1 times 4, right? So now I can simplify both of these. I know this is I, and I know the square root of 4 is 2, so I call it 2I. It's standard to put the I after the coefficient. Okay, so then we have 9. This one, again, will be 3I because we separate it just like we did up here. Number 4, 5I. Number 5, 6I. Go ahead and pause me if you're ready to just continue and see if you can figure it out yourself. For this one, we need to simplify the radical, right? We've got -1. We'll take that out. And then we also have 9 that would go in there, and then 2. So we know we can pull these out of our radical, and that would give us 3I, but then we still are left with the square root of 2, and this is the standard way to write that. Okay, now we have 75. So we'll have the square root of -1 times 25 times 3. So in this case, I would pull out the -1 and the 25. So this is 5I square roots of 3. This one here, we know we're going to have an I out front, right? So I can just pull that out this time if we're ready for that. And then I have 100, which is my perfect square, times 2. So I know this one's going to be 10I radical 2. Down here, 51. So 51 doesn't have a perfect square, but I can pull this negative out. So I can call it I square roots of 51. And down here, this negative is not in our radical, and therefore we do not have to think about it as imaginary, right? We can just write, well, this right here is doable. So we just bring the negative with us, and then we write 12. So this is actually -12. Okay. For this one, we need to find the values of x and y that satisfy the equation. So this is a complex, we have real numbers, which are this one and this one. And then we actually have our imaginary numbers, right? Which are this one and this one. So we can just set our reals to our reals, our real and real over here, and then we can set our imaginaries to our imaginaries. -7I equals yi, and then we just solve. Okay, so a lot of kids try to make this a lot harder than it is, and I want this to be simple. Reals to reals, imaginaries to imaginaries. So for here, we just divide by 2 and x equals 5. Done. For our purple guy over here, an imaginary one, remember I is not a variable, right? It's not, we know what I is. It stands for the square root of negative 1, but it's not a variable that we're solving for. So for this case, we would just divide this one by I, because we'll get y by itself, and divide this one by I. So I over I is 1, just like any other constant, and negative 7 equals y. So in this case, we used imaginary numbers to get to a real number, which is why Euler's invention was so important to mathematics. Okay, pause me, and then I'm gonna work these out in case some kids need it. But pause me if you need to, and I'll work these out, and you can fast forward and see if you got them right. So we'll have x equals 9 in this one, and then 3i equals negative yi. Divide by negative I, divide by negative I, and we get y equals negative 3. Next one, 9 equals negative 2x. So x is going to equal negative 9 halves. And over here, we'll have 4yi equals 3i. We're solving for y, remember? So we just divide by 4i, because that's what we don't want. Okay, these go away, these go away. Now we have 4 equals, or y equals 3/4. Okay. Adding and subtracting. So you guys can do this horizontally or vertically. If you do it horizontally, you have to remember to distribute a negative, just like with any other parentheses. When you're doing it vertically, you don't have to remember that as much. So I'm going to show you vertically on the second one here, and then we'll do horizontally. So vertically, you would just say 7 minus 6i, and then you put a big old minus sign out here because you can't forget to subtract each term, right? And do that. So 7 minus 3 is 4, and negative 6i minus a negative 6i, which is really negative 6i plus 6i is 0. So the answer to this guy is just 4. When we do it the other way, we have to distribute that. So I encourage my kids to do 7 minus 6i and then rewrite everything. Minus 3 minus a negative 6i, which would turn to plus 6i. And now you cannot worry about the negative, and every term has the sign in front of it that is correct. So 7 minus 3 is 4, and then these guys go away. Okay, so again, go ahead and pause me. I'm going to work through the top one here. We'll do 8 plus 5 is, what is that, 13? And then negative I plus 4i is 3i. With addition, you don't have to write it out like this, but I encourage my kids to do it with the subtraction. This one, I would encourage you to write it out. So 13 minus 2 minus 7i, right? Right there, plus 5i. So then we'll have 13 minus 2 is 11, and negative 7i plus 5i is negative 2i. Okay, and this is a complex number, right? It's a real number with an imaginary number, which makes a complex number. All right, here's some more practice. Go ahead and pause me if you need to. I'm going to write it all out. Here we go. So again, minus, and then minus a negative is plus. So here we'll have 3 minus 8 is negative 5, and then 7 plus 2 is 9i. Okay, this one here, minus 1 minus I minus 5 minus 9i, right? Distribute, and then this, the ones. So negative 4 minus 1 is negative 5. So we've got negative 5 there, and then let's take care of that guy too. So we'll have negative 10, and then we'll have negative 10i as well. This one here is 6i plus 4 plus 7i plus 2. So for this one, we'll have 13i and then 6. So don't leave it this way. Write your imaginary numbers second. So this would be the standard way to write this. That's correct. Okay. All right. When we're solving, you guys know how to solve by taking square roots. now we can start applying those I's to those answers and actually not just be able to say, no, there's no real solutions. We can actually say there are two imaginary solutions versus just saying no real solutions. So take a look at this one. You guys already know how to solve this. So plus 4 equals 0. And then x squared equals negative 4. Now, at this point, most of my kids last week would end up saying, oh, well, it's a negative. It's no real solutions, which you're right. There are no real solutions. It doesn't cross the x-axis. However, we can still write the imaginary solution. So we're actually going to say x equals plus or minus 2i. Okay, so just simplifying that, but then remembering when we're solving, we have to consider the plus and minus option. Okay, next ones. So let's add 11 here and add 11 here. We'll get 2x squared equals negative 36. Divide by 2, so x squared equals negative 16. And now here we go again. We got a negative, so we got to square root both sides, and x will equal plus or minus, and the square root of 16 is 4, and so we have a nice square there, and then I. Two solutions, two imaginary solutions. Okay, so write those notes down if you need to. All right. Go ahead and pause me. I would pause this video, but the new program I'm using doesn't let me like stop and start, so I just got to keep going. So pause me if you need to. Go ahead and try some of these. I will write all the answers down for them, and then you can take some notes and figure out which ones you want your teacher to go over during class time. So for this one, we just take the radical, and we'll get x equals plus or minus I radical 13. The second one, same thing. In this case, we've got to simplify. So we're going to get x equals plus or minus 4i root 16 or root 2. And that's because this 38 can break into, we'll have an I out here, and then it's 16 times 2, right? And then we get 4i. Next one, subtract 11. X squared equals negative 8. I guess that's the one. And then x equals plus or minus 2 root 2, 2i root 2. All right, getting a little bit harder as we go down here. So we'll have x squared equals negative 28. And when we square root both sides, we have a plus or minus 2i, because 4 times 7, right? Root 7. It's too green. Add 7, add 7. 3x squared equals negative 24. Divide by 3, divide by 3. X squared equals negative 8. So then again, x equals plus or minus 2i root 2. And I don't have a ton of room to show you this one, but we will figure it out. So we need to subtract 33 first, right? And we actually get 5x squared equals 30. And so then x squared equals 6. So x equals plus or minus I root 6. Whoa, what happened? There we go. Okay, so find the zeros. I've warned my students, and I believe most of you guys should know from your teachers that a 0 is an x-intercept. So sometimes we refer to those in they look a different way, but we refer to them as factors as well. So factors, zeros, x-intercepts. all the same thing. So for this one, we can factor out what we want here. And so they both have 4 in them, right? So let's just call this function f of x is 4 times x squared plus 5. Now I know with the zero product property that this is equal to 0. So I can set it equal to 0 and solve. Subtract 5, x squared equals negative 5. And of course, it has an imaginary answer. So x equals plus or minus I root 5. 2 imaginary answers. All right, let's go to the next one. Go ahead and pause me if you would like to. And then let's see if you guys can do these ones. The zeros, again, the x-intercepts. So we're going to set these equal to 0. So we'll have 0 equals x squared plus 7. Subtract 7 is negative 7 equals x squared. Square root both sides would give us plus or minus I root 7 equals x. This one, we'll set it equal to 0. 0 equals negative x squared minus 4. Add 4. 4 equals negative x squared. Divide. Okay, and then we have to square root both sides. So we get plus or minus 2i as our answers. And the last one, 0 equals 9x squared plus 1. Subtract 1 equals 9x squared. Divide by 9. Now, what you guys need to understand for this one is that a square root can actually be, so when you take a square root, yes, it's the square root of negative 1/9, but it can also be the square root of negative 1 over the square root of 9. And we know that that equals, well, we can do the square root, we can call it I, and the square root of 1 is 1 over 3. So we can actually just draw it around my face. 1/3 plus or minus, sorry, 1/3 I, or I over negative 3. All right, so this is where we get into what happens when we multiply I by itself lots of times. This actually gets to be the interesting part because we can turn imaginary numbers into real numbers. So for these problems, these 4 right here are your most important ones. They are what you're going to want to memorize in order to know all I powers. So I is the square root of negative 1. So we know this little guy is just called I squared. So if you think about negative 1 times this, or the square root of negative 1 times the square root of negative 1, we know the radicals just drop off in this, and it actually just equals negative 1. Okay? Then we have I to the 3rd. Well, that's really just I squared times I again, which is really just negative 1 times I. So we're just going to call this guy negative I. Now, when you think about I to the 4th, we can just think about one that's simple, right? I squared times I squared. That's the same as I to the 4th. And so when we think about that, we can say, well, negative 1 times negative 1. Ooh, my handwriting's getting sloppy. That's just 1. So these 4 are so important, and they are what you guys are going to want to memorize. Whoops. I wanted to highlight that and that and that and that. That's what you're going to want to memorize because we're going to see that pattern repeat over and over and over again. So for our next column here, when you think about this one, well, you can say, well, I to the 4th, that's just 1, and then I have an I. So I like I to the 4th. We know that's 1, and then I have I, so I'm going to repeat and go I there. I to the 6th, well, I can just say that's I to the 5th times another I, right? And so what we get here is just negative 1. I to the 7th, you can make any combination of these that you want, right? We can just, we can call it I to the 6th times another I, right? And this is just I to the 6 times another I. And we know I to the 6 is -1, so then we know this will just be -I. And this guy is just I to the 4th times I to the 4th. And we know that is just 1. So we have, again, I, -1, -I, 1. I, -1, -I, 1. I to the 9th, again, will be 1 after that, which is I. I to the 10th will be -1. So I to the 20th, 20 is a multiple of 4, right? So we can say that this one is just going to be 1 because it can be I to the 4th to the 5th. And we know 1 to the 5th is still 1. And then 21 is 1 after that nice one. So 1 after this nice one brings us back up to the top. That's I. Okay. The way I think about I to the 58th. So I to the 58th, the closest number that's a multiple to that has a divisor, a factor of 4 is 56. So we're going to say I to the 56th, right? And then how many more do we have left after that? Well, we have I squared after that. So I to the 56, we know that's just 1. And then we know I squared, well, that's just -1. So we know we have -1. It makes it very nice. 107 is 104. So the closest one we have here is 104. And then we have 3 more left. So really, this just turns to 1, and we really just have to decide what I to the 3rd is. And we know I to the 3rd is -I. Okay, so it's just a pattern, and it's figuring out that puzzle of the pattern. This is a good one to take a picture of. All right, so now we get into more complex numbers. So a complex number, A plus BI, A is the real part, BI is the imaginary part. So let's write this down. I is just I, right? I squared is -1, and then -I, and then 1. So it goes imaginary, real, imaginary, real. So when we multiply them, we're going to distribute just like you would. And so we'll have -36I minus 24I squared. Well, we know that I squared is actually -1. So -24 times -1, that actually just turns into plus 24. And the more we do a lot of like foiling and distributing, you'll get to realize that the last term, we're always just going to switch the sign before it when we have an I squared. Okay, so this is not a standard way for an answer, so we'll change the real number to the front and put the imaginary number in the back. 24 minus 36I. So for this one, this actually means 2 plus 5I times 2 plus 5I, right? We cannot distribute an exponent, which we've talked a lot about in class. So for here, we're going to have 4 plus 10I, right? The 2 goes to all these things, and then the 5I goes to all these things. So then we'll have plus another 10I plus 25I squared. Okay, so again, we have 4 plus 20I plus this guy turns into a -1. So it'll be minus 25. And 4 minus 25 is -21 plus 20I. All right, go ahead and pause me again and do these other 2 right here. I'm going to talk you through 2, and then I'm just going to write the answer for this one because I don't have a ton of room. So we've got -40 minus 35I minus 64I minus 56I squared. So again, we're going to change this guy to -40 minus 99I plus 56 because this is a -1, right? And so a -56 times -1 is plus 56. And we'll have 16 minus 99I. Your real number's always first. And then this bottom one here, once you work it, make sure that you get 7 minus 16I. All right. moving on. All right, so for this one, we have to think about a conjugate. So this is just an introduction to a conjugate. What happens to these numbers as we distribute them and FOIL them out? Well, 3 times 3 is 9. Then we'll have plus 6i and minus 6i. And then minus 4i squared. Okay, so what ends up happening here, the important piece of this is to know that our positive 6i and our negative 6i actually go away. And then we have negative 4 times I squared, which you guys know I squared turns into negative 1. So we just have 9 plus 4, and we get a whole number. So the importance of a conjugate is to get rid of the imaginary numbers. We've talked about rationalizing denominators before and how there can't be a radical or a square root or a third root of any kind in the denominator. So in honors geometry, you guys did a lot of like 2 root 2 in the denominator. Well, then we said we can't have that, so you had to rationalize it. This is another way of rationalizing it because I remember is a radical. It has a square root. So to do that, all we did to get rid of those imaginaries, we just kept this number, kept this 3. We changed the sign in the middle and then had the same number on the ends. Okay, so the complex conjugates of these numbers, if we want a positive real number, is negative 7 minus 8i. A lot of kids will change the sign in the front as well, and that does not work. So make sure when you FOIL it out, you get positive real numbers. Bottom one would be 5 plus 3i, and 4i would just be negative 4i. Okay? All right, so when we divide complex numbers, we need to simplify this denominator, right? We have to multiply both the numerator and the denominator by the complex conjugate because that's just 1. And we're not actually, we don't want to change the value. So we can't just square this, right, to get everything to go away because it changes the value. We actually have to just multiply it by the conjugate. So let's multiply the bottom by negative 9i and the top by negative 9i. I did this somewhere over here. Let's make sure. So when we multiply these together, we'll have negative 72i over 9 times 9 is negative 81. And then we have I squared. So this I squared becomes a negative 1, right? And we get negative 72i over 81. So again, the denominator ends up being a positive real number. The bottom, the complex conjugate, to get that I out of the denominator, the complex conjugate is negative I minus 2i and negative I minus 2i. So here we have negative 80 minus 20i. And then on the top, or on the bottom, we have 64, right? And then plus 16i, and then minus 16i, and then minus 4i squared. Shoo. Okay, so we got these guys going away. And then we'll have negative 80 minus 20i over 64 minus 4i squared, right? But the I squared turns to a negative 1, so we'll just have plus 4. Okay, this 80 and this 20 have a lot in common. So let's actually pull a 20 out of them. You can even pull a negative 20 out of the top because sometimes we can get that to cancel out with the denominator. So if we pull negative 20 out on the top, that leaves us with 4 and then plus I. And then on the bottom, we get 68. So then we can start canceling some things out, right? We can divide each of them by 4, And we'll get, sorry, my brain's not working all the way, plus I, and then 17 on the bottom. This is wrong. So I need to rewrite it so I can confuse everybody. Okay, so if I want to divide this piece here by 4 and divide this piece here by 4, that would be simplifying that fraction. So then I would have -5 and then 4 plus I, and then I would have my 17 on the bottom. Okay, so just simplifying that, which we can do because we have multiplication. All right, try these problems on your own. I am going to just write down these answers, and then, actually, no, I'm not. I'm going to walk you through them because I didn't write them down. So here we go. Pause them, try them on your own, and then start me up again. All right, so then this guy turns into positive 25. It goes away, right? And then this guy turns into positive 10 because that goes away. So we'll have 10 minus 20i, right? Because we write our imaginary second over 25. I can see that all of these divide by 5. So I'm going to divide this, and this by 5. Because I don't have a 5 out here that's multiplied to both of them, I actually have to divide both pieces because they're separate terms, right? So 10 divided by 5 is 2, and 20 divided by 5 is 4, and 5 divided by 5 is 5. All right, next one. 3 minus I is the conjugate here. So we actually have 15 minus 5i. Boys, I need you to be quiet right now. Minus 6i plus 2i squared. And on the bottom, I have 9 minus 3i. Whoops, 9 minus 3i. Whoops, this is supposed to be plus. Oh, no. The conjugate is positive. All right, now we'll have some things cancel out. So we'll have 9 plus 3i minus 3i minus I squared. And on the top, we'll have 15 plus 5i minus 6i minus 2i squared. Okay. 5 minus 6i is negative I. So 15 minus I plus 2 over, these guys go away, and this turns into positive 1. So we'll have 10. So we'll have negative, oh, whoopsies, not negative. 17 minus I over 10. All right, go ahead and write down the second ones. If you guys have any questions about those ones, your teachers can help you. The conjugates for both of those are 8 minus 3i. And then the other one is still a negative 3 on the bottom, but then it's a minus 3i. Okay, a lot of kids mess that up. All right, try your answers on those. And then here's some challenge problems. If you guys have questions, please write them down. Write down the slide number or the time in the video, and teachers can go over them with you. I hope you guys have a great week.